Yeah. Yeah, it means people mostly always care about the end result, and that's what they think means what success means. But it's actually the journey that defines the success.
That's just one quote.
That's one quote.
No, but like it's out of after.
No.
What?
No.
Yeah. No, it's after. Then the made.
I've never heard a
The
quote
end
like this.
justifies the means. More thing that
Yeah.
came up.
And it's more famous.
Well,
The end justifies the
did you make
means.
that?
Yeah, I made that up.
You made
Yeah.
that? Oh, that's cute. Way to go,
Okay.
Jake. So,
All right, so let's get started.
yeah. I'm gonna write a book.
I do have a fiction novel that I want to write,
Oh my god.
but I don't have time to do it. So you know how we have x squared plus y squared equals to, what do, 1? Like say the radius is 1 or something, right? And then that would be a circle with, like that. Is that the right triangle? Yeah. Okay. Like this. Hyperbolas are like that, where we have x squared minus y squared equal to 1. Did they cover this in class?
No. That's on the
Videos?
Yeah.
Okay. So in this, we have normally cosine squared plus sine squared equals to 1, right? What do you guys think this will be? Yep. So there's essentially some very key differences. And this actually, the triangle will be x, y, like that. There's some very key differences which you just have to memorize. And then there's some definitions of sinh and cos and stuff, which I'll just tell you guys. Sinh of x is equal to e to the x minus e to the minus x all over 2. Cos of x is equal to e to the x plus e to the minus x over 2. Using manipulation and stuff, and if you can find this in integrals, you can convert back to cos and like that, okay? So it helps simplify integrals or do natural logs and stuff. So what would tangent be? Or tan with an H? Okay, you guys realize that? And then secant would be 1 over cos, like that. So essentially you only need to know those 3.
There's 26 different like things.
Yeah.
Yeah, like
For those definitions you need to know that sinh is odd, so of negative x is equal to negative. You need to know cos is even, so this is odd. And I'll forget to write the H. Just remember that. And then there's a whole bunch of identities like cosh squared minus inch squared equals 1, and those, and I'll post those on Blackboard. And you will need to know them. You need to,
Is caution plus inch x. Even the negative x. I memorized it.
oh,
I did.
the derivative of
Oh, yeah.
sinh is cosh. The derivative of cosh is what? Sinh without, so not a negative. Okay, so it's not a negative with the derivative of cosh. 10 is secant squared. The derivative of secant, what? Because it's with respect to, oh, it should be x.
I just thought maybe I didn't understand.
No, it should be x, but a lot of things, when you, besides calculus, you use d over dt for everything. So I guess that was just me thinking about other things. The derivative of secant, or however you would say that, is negative secant of x and 10h of x, however you would say that. So the other difference is the derivative of the hyperbolic secant is a negative. So this is the difference, this is the difference. And those are the two main differences. So yeah, those stay the negative. Cotangent hyperbolic stays a negative when you take the derivative of it. You do not need to memorize the derivative of the inverse of secant and inverse of cosh and stuff. Those will be given to you on the exam. Like this. So the inverses will be given. Okay. So these will be. Good.
But, is the part where singe equals, like, not the original part, but just equals natural log, do we need to know that?
What?
So like just singe by itself is like, has its own like natural log and stuff. Singe x, inverse singe of x is like natural log of x plus square root. I think it's x squared minus 1.
I don't know that. You may need to write it down. Maybe I'm not hearing it. Okay. How are the quizzes on Fridays? Are they relatively easy?
Yeah, give us no questions, but like, you don't know what's gonna be on them the next day. No, do I need to memorize all the quiz? They usually have like.
See, normally I would have done a SI session on Wednesday, but this year I'm really busy on Fridays too. So, like this is the only free time I have because my classes are over. So then that's why they're on Fridays now. Okay. So we're gonna do some problems now, like the exam problems. So if they're given us a sinh is equal to 4, we'll make that up. Sinh of x. We have to find cosh of x. Okay. What famous identity will we use? Cosh squared minus sinh squared equals 1. And then we substitute 4 in per sinh squared. So cosh squared is equal to 1 plus 16. Okay. So then cosh is equal to the square root of 17. So then cosh of x is square root of 17. Cotangent or cot of x would be what? You guys will square root of 17 over 4. Did that make sense? Because this is cosh over sinh. Those sort of problems should be relatively easy on the exam. So if they give us a tangent of x or h, tan of h, what do you guys think we would use?
Like use the same thing, but make it correct standard by dividing by.
So you need one of these with a tangent of h in it. Yeah. But something that it's the same thing, but essentially it simplifies down to 1 minus tan of h squared equals to secant squared or secant. Yeah, so you essentially divide everything by cosh, and then you get this identity. So if in a problem we're given the hyperbolic tangent of h equals to say 5, you would use that to find secant, which is 1 over cosh. Did that all make sense? Yes? Are you guys good with half-life and stuff? No?
Are they gonna give us any like equations on the test, like equations?
Not really.
No. Are we have to memorize like compounding interest?
No.
I don't know.
See, they might, but they didn't test us on it. So
They test you on
no, it wasn't in our exams.
it?
Yeah.
Compound interest or how much?
Compound interest. Yeah.
Where's the cosh? In Stitch, is 0 for cosh, is that the simple one?
I kind of dropped it.
That's a really good
I
question.
can 0 to like cosh, a 0.
That's
Because in class today, it was like Stitch is 0, and that equals 0.
Because I'm not sure every one of those ones.
cosh of 0 is equal to 1.
Cosh is 0.
What were they doing today with ours? Let's do the growth stuff first.
I was late. I wasn't there.
Okay.
That's great.
Let's do the best way to simplify cosh of 0 or sinh of 0 and all of that is to put it e to the x minus e to the minus x over 2 or something like that and plug in what they tell you. That's the only way I can think of right now. So for
It's not because like cosine of 0 is 1, and like sine of 0.
no, it could be, but think of it the other way for right now, because I haven't done these in a year, essentially. Carbon 14 half-life is equal to 5,700.
That's the only one that's
Okay, so it's the first question is find EK of that. So what's the equation? Oh, and they do actually give it to you.
Did they really?
Yeah.
That's like, we really shouldn't be like this amazed by that.
You should be blessed. Yeah.
Like at other schools, that wouldn't be a big deal. But like, yes. Oh my God.
So find EK, that shouldn't be hard, right? Did I write it right? Yeah. Because 1/2 AO is equal to AO e to the KT. And then, yeah, we just have to solve for e to the k. How would we isolate 1/2?
Oh, because it's half life, you plugged in
1/2.
1/2.
Yeah.
What is A? What is it? A? So what are those?
What?
A. What is A and A0? Amount?
Initial amount. These are initial amounts.
And then A is final?
A is like you put in a certain time, and then you have your k factor e to the k with the initial amount, then that's this final amount after a certain amount of time.
Okay.
So we're trying to find what e to the k would be in this case. And we know that the half-life of carbon is 5,700. Okay? So now we have 1/2 equal to e to the k times 5,700. Right? So how do we get e to the k alone?
5,700 divided by 2 is e to the k.
Not divided by 2.
Well, over 2.
Yeah.
Yeah.
So
1/2 1
Oh,
over
okay.
5,700 is equal to e to the k. Did that make sense?
I guess so.
It's like if e to the k was 1/2 times 1 over 5,700, okay? We multiply that by 5,700, we would get 1/2, which is what it's supposed to be equal to.
Why can't you say natural?
This is a quicker way. This is using properties of exponents, but I've never done it. We can try it. What?
That's how my math does work.
That's how MATLAB does it?
Yeah.
We can try it right now. Yeah, let's do it.
It might be a different problem, but it's the first one.
I mean, yeah, I'm sure in the end it might work out. So
Half life.
natural log of 1/2 is natural log of 1 minus natural log of 2 equal to the natural log of e to the k to 5,700. So this is trying to find out what k is, not e to the k, but okay. This is trying to find out what k is. They asked for e to the k. So then you would want to do it this way. But if we do it this way, natural log of 1 is what? 0. Isn't it 0? Yeah. So then we are left with minus natural log of 2 equals to k times 5,700, which we bring down, and we get k that way.
Oh, so if they ask for for K, then we do it.
Yeah, then you would do it this way.
Would they ask for top K or just e?
They'd probably ask for e to the k.
Wait, no.
This is
So it's minus ln2 equals K. So what?
We can use that every time, like natural log 1 minus natural log 2.
no, that was because we had 1/2.
Oh, okay, never mind.
Yeah.
Got it.
That makes sense.
Okay, after we find e to the k, then what fraction percent has not integrated or has not disintegrated in 2,000 years? So I erased it, but so our equation was A is equal to AO e to the KT, right? We found what that was. So A is equal to AO times 1/2 T over 5700. They want the fraction which has not disintegrated, okay? That would be the amount left divided by AO. Okay? That's the fraction that is left.
Left is what your final amount over what you started with.
This is the amount which is left. Like, that's what half-life gives us. In this equation, we start off with this amount, okay? You do this, the A which is left is the amount after 1/2 of that life. So after 5,700 years, and you started off with 14 carbons, you'd have 7 carbons left. It gives the amount that is left, okay? Yeah, so you can, so they want a fraction.
Oh, that's it. Oh, you use A over A0 just for fraction.
Why do they do 1 minus? So we have T is equal to 2,000, okay? So we have 2,000 here. Oh, wait, never mind.
Or that's why they did 1 minus. That we said, because Charles needs to know what's going on.
Yeah, they did 1 minus because that's the amount that has disintegrated. Okay? So, okay, let me explain that again. This is the equation for half-life. Okay? This is your starting amount. After a certain amount of time, this is how much you would be left with. Okay? So if we started with 14, we'd be left with 7. They want the amount that has disappeared. Okay? So with the fraction A over AO, that is a fraction that is left after a certain amount of time. Okay? They want a fraction, but a fraction of how much which is gone. So then it'd be 1 minus A over AO. Okay? This is the percentage that is left after T.
Yeah.
What?
Shouldn't it be 7?
In my example, it'd be 7.
Well, whatever number they gave us when you divided by 6.
No, because that's assuming we went 5,700 years. We are only going 2,000 years.
Oh.
Yeah.
Why are you doing 1 minus? Why are you doing A0 minus A over A0? Why are you doing like what you started with minus what's left?
Because this is like, you can simplify it to get there, but essentially it's the total 1 minus the amount which is left that gives you how much is gone.
So the 1 is the A0 over A0, or A or
Yeah.
A.
Oh.
That makes sense.
Would you guys rather think of it that way?
Yeah.
Really?
How is it?
Oh,
that's how
to learn it.
Yeah, I would think of it,
Or
and then
A0 minus A
No.
over A0.
it would be
No, no.
Is that what you're guys?
A0 minus A, the whole thing, over H.
That's not
It
the
leads
same
to
thing.
that, though.
That's not, those aren't the same thing.
Oh,
Those aren't the same thing. Those aren't the
Okay,
same thing.
now,
Yeah, no,
Yeah,
Austin
yeah,
can't
put it
even
over
say
it.
it right.
Oh,
You can't just divide by
Yeah.
Yeah.
No.
No, that's what you start out with.
A0 over A0 is just 1. That's not, you didn't start out with 1.
Yeah.
Oh my god.
But why would you want that? Doesn't this make more sense?
That makes more sense after us being bad.
Really? My mind directly goes to this because this is like out of the total amount, and this is a fraction.
I'm not.
But we didn't know that was the total amount.
Okay. Well, we'll just keep going. Sorry if you guys are getting bored or something. Okay. Okay, so we have that, right?
Right.
Okay, remember that.
Oh, I need it. Okay.
So then the amount that is left is 1 minus A over AO. That's equal to 1 minus what we had of what did they do?
Oh. I thought we were everything. Don't worry.
So the answer would essentially be 1 minus 2,000 over 5,700. Did that make sense? Or let me say that again. Okay. This is what A over AO is equal to. So then we substitute that in for this quantity, and we have that answer. Did that all make sense? Somewhat? Because this will be like, I'm 100% sure like this is going to be on the exam. So I'm going to redo it now. Sorry about all of that. Yeah, make sure you guys all understand this problem. We found that e to the k is equal to 1/2 times t over 5,700. You guys all agree with that? Given t is equal to 2,000, we can just plug that in, and that would be our e to the k. Yes? We have the formula a is equal to AO, in turn would be 1/2 times 2,000 over 5,700. If they're asking what is gone, it would be 1 minus A over the initial amount. If we divide both sides, so if we do A over AO, that's equal to AO divided by AO times 1/2 20 over 57. Because we want A over AO, we plug that in here, and our answer of how much is disintegrated is 1 minus 1/2 20 over 57. Okay? Now, if they wanted how much is left, what would our answer be? A over A naught would be our answer, which would just be 1/2 20 over 57.
You say how much is left, they're asking for a fraction, right? Because
Yeah.
A is the amount.
They don't
that's
want you to
left.
simplify this.
Oh,
A is the amount that's left.
Yeah.
You have to do weird stuff when they say.
How
add
much is
fraction.
gone? Yeah. When they ask how much is gone, we do how much is the total fraction, which is 1, minus the fraction of how much is left to find how much is gone. Make sure, okay, so any questions on this problem, because I can guarantee this will be on the exam. Or a version of this problem.
yeah.
final answer is.
Yeah,
Do they give you like what A naught is and stuff? Or is this just
they don't need to, it goes away. In this problem, with carbon 14, they don't need to, because how much is left will be that in that time period. Okay. And this is a fraction of how much is left, So if we were ever to give an A naught, we could multiply by that to find how much is left. You don't need to worry about that. Sorry to the people who are going to watch the video. No.
I'm sorry, Lily. I'm sorry, Lily. You're here.
So this is a problem using Newton's law. Is it called Newton's law or something? Newton's law of cooling. Yeah. And they give that to you.
They're giving us so much this time. It's like
You have to know like hyperbolic stuff.
What? Wait, what?
You have to know most of hyperbolic stuff.
Mostly.
Yeah, they won't give those to you.
like the.
Yeah. That is the formula. They tell us an object at 40 degrees is brought into a large enclosure. So they tell us that the object is at 40 degrees, so we'll mark that or T naught. They tell us that it's brought into a large enclosure, which is at 20 degrees Celsius. So then the surrounding temperature is changed to 20 degrees. If it cools to 35 degrees Celsius in 20 minutes. So the object's temperature changes to 35 in 20 minutes. Using Newton's law of cooling, find e to the k. So we're trying to find that, okay? Not t, but e to the k. So one thing that you guys need to be good at is identifying which temperature is which, okay? Like they told us that the object at 40 degrees is brought, so then that would be our starting temperature, 40. They tell us it's brought into a large room that is 20 degrees, so that would be the temperature of the system. Then they tell us that after 20 minutes, the temperature goes to 35. So that would be T, but yeah.
it always has to be like that, right? So it has to be big, not small.
In this, because it's brought into a surrounding with lower temperature, it cools. But in class, you had the example where the temperature went up because it was hotter, the surrounding. So you just have to look at what you have. So then after that, it's a whole bunch of just filling it in. So this would be 35 minus 20 equal to 40 minus 20 e to the k. T is 20. So then e to the k, or e to the 20k would be, so this would be 15, this would be 20, so we have 15 over 20. Okay? Therefore, e to the k would be 3/4, 1 over 20. Now, if the temperature was given in Fahrenheit, I don't think it would make much difference, right?
We would have to convert, right?
No, all
It shouldn't. The units cancel.
It's different always to be that simple because like during our collaborative work and stuff like that, they gave us complicated one. Like it was like no, like the one they gave us in class was like 20 minutes ago, 70. Like, and it started out as 60. We basically have to do like two different, like, solve two different things.
Maybe for the practice or exam, it should be this simple. Actually, on the practice exam, there is not a cooling. On your test, you may have. So this is another example I have from somewhere. So now they want us to find t in terms of natural logs. T as in time. So then we substitute back what that is. This time, they tell us that the object's temperature is 25. So we have 25 minus 20 equals to 40 minus 20.
Is it a different problem now?
No, they tell us that the temperature is 25 and they want us to find the time.
Okay, they say now using what you did.
Yeah.
Something else happened.
And we know e to the k is 3/4. So then it'd be t over 20. Right? This is 15 or 5, sorry. That's 20. So that would be 1/4. We would do the natural log of both sides. Here we have the natural log of 1/4 equal to t over 20 times the natural log of 3/4. Any questions?
What case told
They told you. So now we have, this is minus natural log of 4. Natural log of 1/4 is 4 minus 1, negative natural log of 4 divided by natural log of 3 minus natural log of 4 times 20
equals G.
Any questions on that?
So they're not that bad.
No.
Except for some.
So now we get to cinch and cosh stuff. Is it okay if I erase everything? Using the identity cinch squared equals cosh squared equal to cosh of 2x. And the identity that relates cosh squared and cinch squared, which is what? Cosh squared minus cinch squared equals 1. We have to derive the identity for cinch squared in terms of cosh of 2x. So we have to derive cinch squared in terms of cosh of 2x. Okay. And what other identity do we know? I said it before. Like the Pythagorean theorem version. Okay. So we have to derive sinh squared in terms of just cosh squared. And here we have cosh squared. Here we can find, therefore, cosh squared is equal to 1 minus sinh squared.
Wouldn't it be 1 plus?
Yeah. Very good. Thanks. On the test, you do want to write x's there. I'm just not, good with that. Okay. Yeah. Okay. So then we plug that in here. We have 1 plus sinh squared plus sinh squared. I'll put plus 1 on this side equals to cos of 2x. Therefore, so what would it be? So, overall, therefore, sinh squared is equal to what? So we'd have cos minus 1, first of all. So cos of 2x minus 1, and then it'd be divided by 2. Good? So you'll have a problem like that. Good. Let's do, or can I erase this now? That one was pretty simple though. You'll have some find y primes. Say y is equal to tangent or tangent of hyperbola. And we'll make this cos, or we'll make it cosine.
Oh, you're changing
Okay, so we have to find y prime. What is, so, I mean, this should be really easy, essentially, because
C squared cosine of 2x minus 2 times negative sine x times 2. Yeah.
you guys see how that,
Be the whole test.
but this one, or you can rewrite it or whatever. Now let's make it inverse.
Uh-oh.
Yeah, we do it.
Now
They give us inverses, right?
Yeah. Let me look up what that should be. So the derivative of tangent inverse or of hyperbolic stuff is equal to 1 over 1 minus x squared, where the absolute value of x has to be less than 1. What? Does that make sense?
Charles says it makes sense, so we're
Charles
obviously,
is
we're obviously just missing something.
yeah, we're just.
We're just gonna, I'm not sure about this part. We're gonna move on.
What?
That may or may not be there. Okay. Look in your Dino slides
Oh.
or the videos.
Is there square root?
Okay. No, I know that first part is right. I don't know the restriction or something.
They tell us the restrictions.
Yeah, I never finished.
Yeah, I think like, they're not gonna give you something they can't.
So what would happen? What would y prime be?
1 over 1 minus cosine 2x squared.
Times the root of times negative sine, negative 2x.
I'm sorry. We just did chain rule time.
Good, guys? Did this make sense?
Oh.
It's just working with the different versions of tangent and stuff, but all the rules are the same. You guys good? So this unit turns out to be not as bad and scary as it should be. Yep. Yeah. So now let's do some integrals. Say I have the integral of, we'll go with, I don't know, cosh squared of 3x. What would it be? Cosh is, cause it's cosh squared, we need to, no, not that yet. No. You know we had like cosine squared and you needed to change it into 1 plus or whatever it was. We need to do that.
So the 1 plus.
Well, maybe we use some sense for those. There's a special
No,
idea.
no, no, it's like the cosh 2x minus or plus 1.
Yeah, yeah, something like that. I'm trying to find that right now. Okay. I know it, but you can find it.
It's 1/2 of cosine 2x plus 1.
Yeah. Is it cosine or cosh?
Cosh.
Yeah, cosh of 2x
I didn't write an H like you.
plus 1 all over 2. Do you guys remember doing those with normal cosine squareds and sine squareds? You need to memorize the ones with cosh squared and sinh squared. Okay? So then we substitute that in here. So that's equal to, so looking at that, we can just have a, can we do 1/2 on the outside, right? We'll have an integral of cosh of 2x it'd be 6x of 6x plus 1 dx. Did that make sense?
So the sin squared 6x. What you think? I don't know.
I have 1/12 sin 6x.
No, okay, so just leave the half. Leave the half.
I should.
What is the integral of cosh? Just sinh. I believe it's just sinh.
Yes, it does.
For, yeah, but yeah, if we make our u equal to 6x du is equal to 6 dx, so then we have sinh of 6x all over 6.
Yes.
Yeah? Because we multiply by a 6, divide by a 6 on the outside, plus x. Good? Now let's make this an even harder problem. What did I forget? Plus c?
Yeah.
I was going to add limitations. So say we're going from 0 to natural log of 2. Now what would we do?
changes on the definition.
The definition of sinh
What? Oh,
with the e to the x stuff. So I'm gonna take this away. The definition of sinh. Anyone want to say it? All right. So I'm gonna write this here so we don't forget. We're going from 0 to the natural log of 2. So first thing we need to do is substitute it in. So let's say we still have the 1/2. We substitute that in. We have e to the x minus e to the minus x all over 12. Now let me. No, it might not be that actually.
Oh yeah. Wouldn't it be e to the 6x?
That's what I'm looking at. If it would be that. Okay. Something that we can do before even going there is plug in those values. So let's do that actually. So let's plug in natural log of 2 in there, okay? We'll have sinh of 6 times natural log of 2 all over 6 plus natural log of 2 minus sinh of 0 all over 6 plus 0, so that won't matter. All right. Now let's substitute them in. The definition is 1/2 e to the x, so it'd be e to the 6 times natural log of 2 all over 6 plus minus e to the minus 6 natural log of 2 all over 12 plus the natural log of 2 minus e to the 0 minus e to the 0 all over 2. This would go to 0 because this is 1. That is 1. So that everything goes to 0. Good. We are left with that big equation. So we have 1/2. So this would be 2 to the 6th. So we'll have 2 to the 6th minus, that would be 2 to the negative 6, so 1 over 2 to the 6th. All over 12 plus the natural log of 2. I have 6, but it might be, on the test it might not be that big. But what is 2 to the 6th anyway? 64? So is it okay if I erase and put 64 there? Why not?
why am I asking you guys?
If someone wants to say no, you have to be quick.
What helper kind of it?
64 minus 1 over 64, you guys can do that. I'm not going to do it.
Is that,
You have to multiply 64 by 64.
that
63 and 63, 64. Does that make it?
I don't know the answer. I made this up.
It's 4,095 over 64.
4,095.
409.
What was that combination? Did you just make up the problem?
Yeah, I made it up.
Okay, I was like, why would they make this problem? Like,
Yeah.
Over 12.
Over 12, yeah. And then you have 1/2 on the outside. But the important thing is, do you guys get the procedure? Like how we did it? That's what, the important thing is. And there's one other problem I'd like to show you guys.
Are they gonna ask us to like set it up or just like?
They'll ask you to solve it, and with their numbers, it shouldn't be terrible like this. But yeah, but it won't be like 64 times 64 times 12 or something. But generally, you like even like as you go on, they get worse and worse with numbers. So, yeah, you just have to live with it. The way I normally multiply like 2-digit numbers is, do you guys know this method? So we got 64 times 64. Yeah, do you guys remember this method?
Multiply it.
I don't know the name. So what you do is you multiply 4 times 6, you get 24. You put 24 in the box. 6 times 6 is 36. 24. 4 times 4 is 16. And you add the diagonals. So we have 6 in this box. We have 9 here. We have 10 here. 1 goes up. So 4096.
This is some fancy stuff.
Yeah. So normally on the exam, I do that quickly on the side if I have big numbers. Okay. Let's do an integral of e to the x times cos of x dx. Okay? What would the first thing we would do in this case?
Change
This one we would, add the definition, change cosh. So we would have e to the x times what? So then we multiply that across, we'd have e to the 2x.
Can we move the 1/2 out?
Yeah. E to the 2x, what would that be? E to the x, it'd be 1. Do you guys see how that happened? And say we had, we'll just do from 0 to natural log of 2 again. What would the integral be? What is e to the 2x, the integral of that? I think it's over 2, right? Plus what? From 0 to natural log of 2. So we plug in natural log of 2 in there. We have 1/2 times e to the natural log of 2, or 2, multiply 2 with that, all over 2, plus natural log of 2. E to the 0 is 1/2. Remember, it doesn't go away. So we have minus 1/2 still plus, sorry, it'd be minus a minus 1/2 plus 0.
Wouldn't be, wait, you said e to the 0 is 1.
Yeah, sorry, I said that before.
No.
Did that make sense?
Isn't, so if e to 0 is 1/2, shouldn't be 1/4 then? Since you have the 2.
I still have that.
Oh, wait.
Yeah.
e to the 2x over 2.
I plugged in the natural log of 2. I haven't multiplied that across yet.
No, I know, but like you say e to 2, e to the 0 is 1/2. Right?
No, e to the 0
Oh,
is 1,
Okay.
but it's divided by 2.
Yeah, it works that way.
So then you simplify that. You guys can simplify that. Okay. Did this make sense?
Did you bring the 2 from in front of the natural log to the power?
Yeah, so then these would cancel, you'd have 4.
Yeah.
So the answer wouldn't be bad. Oh, I'll just write it here.
Hey Daniel, that close parentheses you have, is it like not really, it's like a continuation? That right there, like click line, that,
This,
yep,
this, right?
is that like still a part of, so you're doing e to the 2 and blah blah plus ln 2?
This is when I plug in.
The
It's
1/2
one
goes-
giant parentheses, right?
the 1/2
Yeah,
goes-
these two are 1 giant parentheses.
Okay,
This is when I put in the top upper limit.
okay.
This is when I put in the lower limit. So then if we were to quickly simplify that, we have 1/2 times 2 plus natural log of 2 minus 1/2. So then we have 1 plus natural log of 2 over 2 minus 1/4, right? So that's equal to natural log of 2 over 2 plus 3/4. So any questions on this sort of problem? That you guys did in class?
Yeah, they were all like parts and we'll remember rotating stuff about axes, right?
So was it the one, are you talking about the one where y is equal to cosh of x? Okay. Are you guys good with this problem? So one of the things in the exam is you'll need to recognize when you have a definition of a cosh in there, or when you'll need to plug in the definition of a cosh. Sometimes you may need to multiply by a value like 2 to get it to the definition of a cosh or a sinh. You guys get what I'm saying? Because it's divided by 2. So then you make the substitution, and then the integral becomes easier. So this is the one you did in class. V is equal to, let me draw the graph. So this is 1. Yeah. So you have to find the volume as it rotates about the x-axis. Did they tell you that the radius is equal to cosh of x dx?
I feel like we're supposed to figure that out on our own.
since, so if it's rotating about the x-axis, okay, you can say that the radius is to it, which would be y equal to cosh of x. So normally volume is equal to pi from the limit, in this case we have 0 to 1, of r squared dr. We make the substitution. Pi from 0 to 1 of cosh squared of x dx. Did that make sense?
So then you just do regular.
Like the example I showed you before, cosh squared x is equal to 1 plus, or cosh of 2x plus 1 over 2. And you do the substitution, and it's just solving the integral.
Is it always just higher for DR? They're not gonna make this revolve around the y-axis and then you need to figure out the shell, washer, crap.
On this practice exam, they don't have volume. Okay?
So volume fire square DR. The interval, whatever. That's always the thing.
I don't remember.
I don't remember either, but he was like, you guys
I would just go with that, yeah.
just go with D with fire.
Because we have the area, and then the pi r squared would give us the area of the circle, and then dr would be that element.
Okay.
Why, yeah, we'll go with that.
Okay, that's not too bad.
I doubt you'll have any volume problems on the exam.
We'll just do it in there.
Yeah, for practice purposes.
Yeah.
You'll do more crazy stuff, just to let you know, than what's happening right now. Okay. Any questions, guys? That's pretty much what I have. We went through basically the entire unit.
They are doing the completely online. We still have